Hello friends, welcome back. First part of recursion which we discussed. Remember in the first part I just gave you one example. I explained you pros and cons of recursion. More pros of course, less cons of course. But as I told you, it's a very important concept. Alright. So what I've decided in second part, let's first of all practically write and understand one of the very common examples which we take for recursion, that is finding factorial of a number. There, the stack creation process, if we understand properly, we will have no problem in solving any other question related to recursion. So let me start with that. Remember, finding factorial of a number, like factorial of 5 into 4 into 3 into 2 into 1, like that. It can be done using looping, but this is a classic example. Through this example, let's understand how exactly recursion works. Alright, so no formalities directly. I will have a main function. Okay, I go for integer num, an integer. Okay, I accept this from the user, printf a message, enter number, scanf, %d, ampersand, num. I got the number from the user. Okay, I'll rub this off. These are the lines. You take a number from the, accept a number from the user, assuming till that point. Well, this is the prototype of your factorial function. This is the prototype. Int fact, int, the return type is integer, name of the function is fact function, it takes an integer as argument. This is the first line of your program. Assume before you start main function, you declare the prototype. Got that? Now after I accept the number from the user, get the number from the user, I simply do this printf factorial each %d, comma, I call fact function with num as argument. This line, just understand what is happening. I call fact function will return a value, and that value will be directly displayed over here in main function, and that finishes main function. Assume this is your main function. Got it? Clear? Now let's go to the fact function. Okay, this is my fact function, int fact int n. If n equal to 0 or n equal to 1, return 1, else return n into fact of n minus 1. This is my fact function. Look at this carefully. Got it? Now this line is very important. So look at this line particularly properly. N into fact of n minus, return n into fact of n minus 1. Got this? Clear? Now let's understand how it all takes place. Assume that in main function you accepted num value as 3. Got it? So obviously fact function has its local variable, that is n. This is your formal argument. The actual argument num is 3. So n will hold the value 3 for the first time when this function is called. Okay, now every time a function is called, a stack is created. Remember, we discussed that also. And every time a stack is created, it is created automatically, and stacks are created on top of each other. Called function, calling function, called function, calling function, called function. That is how it takes place. Alright, on top of each other. So let's start with the stack creation process. The first stack is created. Now let's do one thing. This is line 1, this is 2, this is 3, this is 4. Line number 1 is true, line number 2 will be executed. Else if it is false, it will come to else part. Okay, line number 3 is true, when it comes to the else part, so line number 4 will be executed. Got this? So now what happens? Line number 1 is first time fact function is called, and every time fact is called, this variable is there. Understand that. So this stack n is the variable. We assume the value will be 3. N receives a value 3. Got it? First checking is done. If condition is checked, line number 1 is executed. True or false? False. So control jumps to line number 3. The moment it jumps to line number 3, it will go to line number 4. Now look at line number 4. What is the line? Return. I'm just writing it symbolically here. N, what is the value of n? Return 3 into fact of 2, 3 minus 1. This is how it will, and let me write it a bit bigger, okay, so that it is properly visible. N with a value 3, okay. Line number 1 is false, so control jumps to line number 3 directly. From there it goes to line number 4, where the line is return 3 into fact of 2. Now what happens here when you say this line is not completely executed. Before the execution completes, control will jump from here. Fact of 2 is a function call, so obviously control will jump and create another stack where again fact function will receive the value 2, n will receive the value 2 here. Understand how this stack creation is taking place because of this function call. And mind it, this line is not yet completed. So here what happens? N gets a value 2. Here again line number 1 is false. Line number 3, line number 4. Line number 4 is what? Return 2 into fact of 1. So fact of 1 again creates a stack here. This time n has a value 1. Now what happens? Line number 1 is true. If n equal to 0 or 1, true. So what will happen? Return 1. This return 1, where it will return the value? This is the called function, this is a calling function. So obviously this called function, before it completes, it will return the value 1. To whom? To the calling function, that is here. From here the function call was made, so here 1 is returned. Now this line will be completed now. Return 2 into 1, that is 2, and this stack completes, goes away from memory. By that time it will return 2 here to this place, and finally here this line is again executed. Return 3 into 2. How much it will return? It will return 6, and 6 will be returned to whom? To main function. Printf statement will print the value 6, which is the factorial of 3. Hope you understood, friends, how it is taking place. Got it? Now let me tell you one thing. Some programs are there which, like for example, the example which I am going to discuss with you after right now is after some time is reversing a string using recursion. I have seen numerous solutions to this particular question that you can get on Google. If you Google, you can get many solutions, many different types of solutions. But what I found is unnecessarily complicated. So what I have done is I have simplified the program, and here is a program for you. Let's do this. Now why I have taken up this program? Just to show you in the simplest possible way you can solve recursive problems. Got it? So friends, let's have a look at this particular example, and then we discuss it on the board practically through creating stacks. By using stacks, we look at how the recursion is taking place. Have a look at the main function first. I have included two header files, stdio.h and string.h. Okay. Now revstr, which I am saying is Refstring Function. Alright. Refstring Function, that is a prototype. What it receives? It receives a character pointer as argument. Alright. Clear? Then I have my main function. There I take a string from the user as input, then I pass it to Refstring function. Now Refstring function, look at the prototype again, it doesn't have a return type, okay, and what it takes as an argument is a character pointer. Alright, so let's understand main function first on the board, then I'll go to the Refstring function. Here is your main function. I'm just in the execution mode, I'm showing you what was happening there. We accepted a string from the user. Assume that your string is this. The string which you accept from the user is A, N, Y, any. There will be a backslash 0. At end of every string there is a backslash 0. Now this is the 0th character, first, second and third character. This is your string in memory. Assume, let's take some imaginary address. Let's say the starting address is 101. Obviously this will be 102. This is 103 and this is 104. Got it? Clear with this? This is your string. Okay. Now what you are passing? Remember in that main function when you called Refstring function, you passed what? str as an argument. Str means what? Str means the name of the string which holds the starting address. Remember about arrays? Every time you take the array name, you get the base address. Same over here. Refstring function is getting the address of the starting address of str. This is your str. Okay, it receives the address of str as an argument. Okay, let's have a look at and see how Refstring function looks. Have a look. Complicated? Just 3 lines. Just 3 lines of code. Okay, clear? And then let's give them line numbers. If condition is line number 1, then Refstring s+1, that is line number 2, printf %c, star s, that is line number 3. That is how we now discuss the program. When we discuss this particular function, by that time just remember these are the 3 lines, okay, because we will create stack and understand. Okay, and remember the local variable that Refstring function uses is a character type pointer. S is a character pointer. So what it will hold? It will hold the starting address of the string str, which is 101. Alright, clear? Let's go back to the board. Okay, now stacks will be created, obviously. That's what we have been discussing. First time Refstring function is called, a stack is created here. In the stack, obviously it has a local variable s, which is a pointer, character type pointer, and what address first time it receives? 101, the starting address of the string str. Got it? Line number 1 executed. If star s not equal to backslash 0, star s means value at 101. Value at 101 is what? A. It's not backslash 0, null character. So obviously control will jump to line number 2. What is line number 2? Line number 2 is reverse function is called. I am just writing reverse. You understand Refstring function with the address s+1. S is how much? 101. So it will be 101 plus 1, that is 102. And from here control jumps and creates another stack. And please don't forget that here another line is still to be executed, that is line number 3. Got it? Printf statement, if you remember. Alright, I'll show you the slide once again, don't worry. Alright, so what happens here? S has a here again the variable s will be there because it's a fresh copy of Refstring function. S will hold a value 102. Here again line number 1 is true, s has a value n, so line number 2 will be executed. What is line number 2? Refstring of 103. S+1 is 103, no, because s is 102 here. So again another stack is created. Control jumps here, s 103. Again line number 1 is true, 103 is not, value at 103 is not backslash 0. So line 2 will be Refstring of 104. Again another stack is created. S will have the value 104, address 104. Here line number 1 is true or false if star s not equal to backslash 0. Star s is backslash 0, isn't it? Value at 104 is backslash 0. So here this becomes your exit condition. This was your exit condition. So what will happen? From here stack creation stops and stack removal starts. How? Here the condition is false, so line 2 and 3 will not be executed. That finishes the function and this stack will be removed from memory. By the time it is removed from memory, control comes back to this one. Here which line is to be executed, which was left, because from here control jumped, remember. So line 3 is what? Printf %c comma star s. What it will print? S has a value 103, address 103, star s is what? Y is printed. This is complete, stack is removed. Again here control comes here, line number 3, s has address 102, star s y n is printed. Over, control comes here, line number 3 again, 101 is the address with s, a will be printed. Got it? Don't you think this is interesting how it is happening, how this stack creation? Okay, before I finish up, have a look at the function again just to understand how it works. Got this, I hope? Okay, so now friends, that is how recursion is. You know, it's a very interesting concept. If you follow it properly, it's going to be a very interesting concept. Understand that. And you can take up examples. Now a piece of advice for all of you, if you are preparing for test, interview, all these things where recursion as a concept might be asked, it is better practice at least 5 or 6 different types of examples of recursion, where the recursive function will have a return value, it may not have a return value, like we did. Clear? That is how you will improve your understanding of recursion and your program writing skill when it comes to recursion. That's it, friends. Recursion as a concept we have discussed, we have completed. Next time, see you with a new video with some other concept. Till that time, take care. Bye bye.